Welcome to another math episode. Today we are going to learn how to solve compound inequalities. So a compound inequality is just an inequality with two or more inequalities in it. It's usually separated by the word and or it will look like this first question right here. So if you look, there are two inequalities within this problem, and here's how you solve it. When you get this version right here, you're going to want to split up the inequalities. The first inequality will just be this part right here, and we're going to rewrite that on the left side. 36 is less than 11 minus 5x. And you solve it the same exact way as you would a normal inequality. Getting x by itself by subtracting 11. Now I got that as 25 is less than negative 5x. And to get x by itself, I would have to divide by negative 5 right here. And don't forget that rule about inequalities. When you divide by a negative, you got to flip the sign. Now I got negative 5, and don't forget to flip it because you're dividing by a negative is more than x. I don't like writing it this version. I like writing it where the variable is first. And as long as that mouth is facing the same quantity, it's facing negative 5, they both mean the same thing. So this is the answer for that first part. And we're going to graph that right here in this number line. So I'm going to go to negative 5. And don't put it on the main graph yet. Just put it right above a sketch of what that will look like. An open circle at negative 5 and everything to the left because it says less than. X is less than negative 5. That graph will look like that. Now let's do the second part, this part right here. We're going to write that equation on the right side. 11 minus 5x is less than or equal to 66. And same goal, get x by itself. Subtract 11, negative 5x is less than 55. Divided by negative 5. Don't forget to flip the sign. Now you got x is more than or equal to negative 11. We're going to graph that the same way right above right here. So that's going to be a closed circle at 11, negative 11. And everything greater than negative 11 is to the right side. When you're graphing end statements, so now I got my two solution represented as a graph. To figure out what the final product looks like, all you got to do is compare that purple and green line and find the area that they overlap. Find the area that they overlap, or the word intersect, the area that they have in common, which is from negative 11 all the way to negative 5. However, that negative 5, they really don't have that in common because it's an open circle. And that is the part that you're going to shade as your final answer. The area that they overlap, where they intersect, or the area that they have in common. I want you to understand what that means. It means that if I plug in negative 11, 10, negative 9, 8, 7, negative 6, but not negative 5 because that's an open circle, if I plug that in for x, it will make a true statement. It will be a number that's higher than 36, but less than or equal to 66. So let's test that out. Let's just put one number in there in our solution set. Let's put negative 10. That's easy to plug in. 11 minus 5 times negative 10. And this is how you check your answer once again. Plug it into that expression. I'll get 11 plus 50, which is going to get you 61. And as you can see, that number 61 is more than 36, but less than or equal to 66. So that does work. And again, that is how you check your answer. Let's look at another example. Sometimes this compound inequality will have that word and in the middle. So this time, you don't even have to split up the equations. They are already split up for you. First part is just to solve each inequality. We'll start with the left by adding a 13 to both sides. Now I got AP is less than or equal to negative 2 plus 13 is 11 plus 7P. Let's move that 7P on the other side. And I'll get P, which is by itself less than or equal to 11. If I go to my number line, I'm going to graph it with a closed circle at 11, and everything less is to the left. Don't graph it in the main graph yet, because you are looking for where they intersect together, the area they have in common. Looking at the right equation, let's bring all the numbers on the right side by subtracting 20. Now I got 4P is less than 2P minus 6. Bring all the P's on the left side. Now I got 2P is less than negative 6 divided by 2. I don't have to flip the sign. I didn't divide by a negative. So that says P is less than negative 3. So I'm going to go to negative 3 with an open circle, and it's everything to the left. If we look at this graph, you're trying to figure out the area that they have in common, which is only going to be this little piece. That has an open circle, so we're going to put an open circle here. And the area that they have in common is everything to the left. So that means if I plug in a negative 4 for P, or anything less than negative 3, it will make a true statement. I want you guys to try out the problems below and graph your solutions the same way. I try to give you an example of what you learned in the first 2 slides, so let's see what you got. Pause the video, and when you're done with the questions, just unpause it for the answers. Here are the answers for the questions. In the first one, they got the word "and" on it, so you don't even have to split up the inequality. You just solve each one, and you will get these 2 results right here. Once you have those, you're graphing each one. So R is less than or equal to 9 is this one. R is greater than 4 is this one. And you are looking for the area that they have in common. That is what you're shading in the final graph. So this means that if I plug in 5, 6, 7, 8, or 9 into R, they will both make true statements. They will both make true statements. Looking at the other question, if you got a compound inequality with 2 inequalities like that, you're going to have to write 2 equations. One of them is this, which I wrote right here. And the other equation will be this part. From there, all you got to do is solve each one, and B is less than negative 2, and B is greater or equal to negative 4. Once you graph both of those, you're looking for the area that they have in common, and it's all the answers from negative 4, more than negative 4, it can't be negative 4, all the way to negative 2. We will go over what the OR inequalities look like, but until then, I will see you on the next episode. Peace.